Guys, good evening. Hope you guys are fine. So we're talking about electrolysis. Electrolysis was actually gotten from the term electrochemistry. That means using chemical compounds to produce electricity. So you can say electrolysis is under electrochemistry. So now, before we talk about electrolysis, I need you to understand what an ionic theory is. So let me look at an ionic theory. An ionic theory proposes that when an electrolyte is melted or dissolved in water, some, if not all, the molecules of the substance dissociate into freely moving discharge particles called ions. So this shows that before electrolysis can take place, there has to be dissociation. That means the substance has to dissociate freely to produce what we call the ions. I get what I'm saying. So in the sense that if we are to do dissociation of sodium chloride now, dissociation of sodium chloride will yield what? Na plus Cl minus. Cl minus. This is a form of dissociation. You get what I'm saying? So this is the ionic theory. The compound or the substance has to dissociate first before electrolysis can take place, and it has to be in either in solution state or in melting state. So you see it here, either in melted state or dissolved in water. So any one of it. So now let us now look at the concept of electrolysis. So now look at this. For electrolysis, chemical decomposition of a substance can be brought about by heating. Similarly, electrical effects can also be used to bring about chemical decomposition of substances. So now, highlight the word chemical decomposition. The way I would like to define electrolysis is that electrolysis is the chemical decomposition. Electrolysis is the chemical decomposition of substances. Electrolysis is the chemical decomposition of substances in either solution states, or molten states through the passage of what we call direct current. So let's recap. Electrolysis is the decomposition, or you can say it's the chemical decomposition of substances. So those substances either in solution state or molten form. Either in solution state or molten form. Solution state or molten form. So when we talk about solution state, it shows that it should be dissolved. It tells us that it should be dissolved in water. That's for solution state. Then for molten state shows that the substance has been melted. There is a difference between a substance to be dissolved in water and a difference for it to be melted. Like sodium chloride can be dissolved in water. Like lead, 2-bromide can be melted. You get me? So either ways they can be able to dissociate, and in other words they are undergoing what we call chemical decomposition. And what is allowing chemical decomposition to take place is the passage of this what we call direct current. That is why we see the diagram of that electrolysis. That's an electrolytic cell. So this electrolytic cell converts electrical energy into what? Chemical energy. So if you look at it, this is the direct current right here. This is the direct current. Can you see power source? We have some electrolysis stems here. We have anode, we have cathode, which are the what? Electrodes, which allow the passage of current through them. We have what we call the electrolytes too. You get me? So you see these electrolytes. The electrolytes are those substances that can conduct what? Electricity. Example, salt water. Example is salt water. So salt water is an example of an electrolyte, something that can conduct what? Electricity. So don't forget, things that need to be present before electrolysis can take place is presence of direct current, electrolytes or substance in solution state or molten state, you get. And that's pretty much the most important part. So now let's move on to electrolytic process. Electrolytic process involves three steps. It involves what? 3 steps. So electrolytic process involves 3 steps, which are: first one is ionization of electrolytes. Don't forget, an example of electrolyte is salt water. And don't forget also that an electrolyte is a substance that conducts what? Electricity. You get me? Next one, we have what? Migration of ions. When the electrolyte ionizes like this, don't forget the ionic theory. Once it ionizes like this, the next step is for it to move to the electrodes. So that's why we say migration of ions to the what? Electrode. When the ionization occurs in the electrolyte, then those ions will have to move to their electrodes. You get me? So if they are there, they will have to move to their electrodes. So that is migration. You know what migration is? Moving from one place to another. The next one is discharge of ions at the electrode. So after they dissociate, first they dissociate. After they dissociate, they will now migrate to the electrode. So when they now move to the electrode, they will now either they give out electrons at the electrode, or they accept electrons at the electrode. So that is what they call discharge of ions at the electrode. So now let me explain them one by one. So if you look at this, under the ionization of electrolytes, so I told you that electrolytes can be in 2 forms. So electrolytes can be in 2 forms. It's either it can be in solution form or molten form, or molten state, whichever way you want to put it. So when we now talk about solution form simply means that substance is being dissolved in water. Like if I say salt solution, it means salt has been dissolved in water. You get what I'm saying? Salt has been dissolved in water. If I say sugar solution, it means sugar has been dissolved in water. You get me? So that is why I put this what addition of water there to show that solution state contains what water. Now look at an example under solution state. So if they say copper 2 tetrahydrosulfate 6 solution, if they say copper 2 tetrahydrosulfate 6 solution, your mind should tell you, your brain should tell you that there is presence of what water. So that means if this solution wants to dissociate, you will dissociate for the copper 2 tetrahydrosulfate 6 first, and you also dissociate for the water, because they are both together. And when you want to dissociate, don't forget copper on its own is having how many electrons? Oxidation number of what? +2. SO4 having oxidation number of what? 2 minus. You know these ones. H2O, when it dissociates, you'll be having hydrogen ion and what? Hydroxyl ion. That is what we call the ionization, the splitting. You get me? The splitting of the elements into what? Ions and radicals. Remember, this is an ion, this is a radical. What's the difference between radical and ion? For radical, you will have two different elements having a particular charge. But for an ion, you just have a single element having a charge. So now let's move on to the molten state of form. Molten state just simply means what? Melted form, when it is being melted. So as it's melted, it will be able to what? Dissociate. If it is in solution state, it can dissociate. If it is in melted state or molten state, it can also dissociate. So an example is lead 2 bromide. Now this lead 2 bromide, once it's being melted, it will dissociate into what? Lead ion and bromine ion. Lead ion and bromine ion. So like this, as you have given out, as you have splitted the elements into ions, that is what we call the ionization. That is what we call what? The ionization. The splitting of these elements itself. The splitting of the elements is what we call the ionization. So the first step, the electrolytes, which is that substance that can conduct electricity, will split into ions. Now the next step, which is number 2, next step is migration of ions. Migration of ions. So let's take an example here of this one. An example here of this particular one. So now, say migration of ions to the electrode. This one here, copper 2 tetrahydrosulfate 6 solution. Now, remember that when this one dissociates, you'll be having copper ion and so on and so forth. So now, what is an electrode itself? An electrode is the one that allows current to pass through them. And you know, if you read your notes well, you should know that we have two types of electrode. We have the anode and we have the cathode. So you know that the cathode is negative electrode, while the anode is the positive electrode. So now it is logical for you to think that, okay, the ions that are positive will always be attracted by the electrode that is negative. The negative will always want to attract the what? Positive. The negative will always want to attract the what? Positive. The positive will always attract the what? Negative. Remember that like poles repel, unlike poles attract. So if you look at this, these ones are positive ions, while these ones are negative ions. These ones are negative ions, while these ones are positive ions. So if they want to migrate to their electrode, the ones that are positive would like to go to the ones that are negative, which is the negative electrode. The positive ions want to be moving towards the negative electrode, while the negative ions want to move to the what? Positive electrode, which is the anode. So that means this negative one will be going to where? The anode, correct. While this one will be going to the what? Cathode. Let me change the ink. And this one will be going to the what? Cathode. Remember, the cathode is negative and the anode is positive. That is why this anode here is attracting this negative ion, because it is positive. While this negative electrode, which is the cathode, will be attracting the what? Ions, which are positive. So now there's something. Those ions that are attracted to the anode are called the anions, meaning that they are the anode ions. Are you getting what I'm saying? Those ions that are attracted to the anode are known as the what? Anions, meaning anode ions. While those ions that are attracted to the cathode, are known as what? Cations, which means cathode ions, what? Cathode ions. Hope you understand what I'm saying. So don't forget, these ones are ions, negative ions. These ones are positive ions. Positive ions will always want to go and meet the what? Negative electrode. They always want to go and meet the negative electrode, while the negative ions will always want to go and meet the what? Positive electrode. So that's for number 2. So moving on to number 3. So when we look at number 3, we have discharge of ions. So now, first step, you know that they are going to dissociate, that's ionize. Then the next step is that they are going to migrate to their what? Electrode. And the third step now is that they are going to discharge their ions when they get to their electrode. So now, discharging of ions, this involves the gain and loss of electrons at the cathode. Discharge of ions, this involves the gain and loss of electrons at the cathode and anode. Cathode and anode. So now when you look at this, they said gain and loss of electron. I should tell you that at the third stage, what happens? Redox reaction occurs. Redox reaction occurs. So for an example, this is lead 2 bromide. This lead 2 bromide is in molten state. That is why we are not seeing any water being added. Don't forget. So this is lead 2 bromide. When lead 2 bromide dissociate, or ionize, let me put it that term, ionize, we'll be having Pb2 plus 2Br minus. So now at the cathode, the cathode is the what? Negative electrode. The cathode is the negative electrode, and the anode is a positive electrode when it comes to an electrolytic cell. So now at the cathode, between this one that is positive and negative, between the positive and negative ion, which one will migrate to this cathode, being the negative ion? The one that will migrate to the cathode is going to be what? Pb2 plus. Is going to be what? Pb2 plus, which is lead ion. So lead ion will be moving towards the cathode because the cathode is what? Negative. Positive to negative. You get me? So we'll be having what? Pb2 plus. Pb2 plus. Then for the anode, we obviously be having 2Br minus. So now look at this. Look at this carefully.